Welcome to a deep dive today into the life of Srinivasa Ramanujan, a name that you know might not be familiar to everyone, but trust me, this is a story you won't soon forget. We've got a whole stack of biographies and academic papers, all giving us glimpses into the mind of a true mathematical prodigy.
And what's so fascinating about Ramanujan is that his journey wasn't a typical one at all. He was largely self-taught with limited access to formal education, and yet he still managed to challenge and expand the world of mathematics in really profound ways.
Okay, so let's unpack this a little. I mean, we know that he was a genius, but what we want to really try to understand in this deep dive is what made his journey so unique. Like, what can we learn about genius, about resilience, and that pure drive for knowledge?
Those are excellent questions. And, I think a good way to kind of start is with this story from his childhood. Apparently, young Ramanujan was really troubled by the idea of dividing 0 by 0.
Wait, seriously, most kids at that age, they're just figuring out their times tables.
Exactly. Even as a child, his mind was already grappling with these abstract concepts, with the underlying logic of mathematics. He wasn't content with simple answers. He had to understand the why behind the what.
So even back then, we can kind of see that unconventional thinking emerging, and it really took off from there. By 13, he had mastered advanced trigonometry from just one single borrowed book.
Yeah.
That's insane.
It really speaks to just his incredible capacity for self-driven learning. He wasn't memorizing formulas. He was internalizing concepts and applying them in ways that no one had ever thought of before. He was actually rediscovering these established mathematical theorems on his own before he even stepped foot in a college classroom.
It's almost like he was tapping into some kind of hidden mathematical code, and seeing patterns and connections that everyone else had just completely missed.
It's possible. But alongside that incredible talent, there's also this other detail about him that I just find so endearing. It was his fascination with magic squares.
Magic squares. You mean those number puzzles where like every row and column adds up to the same number?
Precisely. It seems like such a simple pastime. But it reveals kind of a playful side to this genius, an early interest in patterns and combinations, even in something as simple as that, a magic square. Ramanujan was drawn to this elegance and this underlying structure.
Yeah, it's a good reminder that even the most brilliant minds have hobbies and passions outside their main field. It humanizes him, makes him more relatable.
Absolutely. But as we kind of delve a little deeper into his story, we start to see the emergence of another theme, and that's resilience. Because Ramanujan's journey wasn't without its obstacles.
Right, because all this genius doesn't automatically translate to success.
Right.
He struggled to get his work recognized.
Yeah.
Because he lacked those formal qualifications, those rigorous proofs that the academic world always demands.
Yeah, it's a classic case of someone whose ideas were so far ahead of their time that they couldn't really be understood or accepted easily. He failed his college exams, not because he wasn't brilliant. It was because he just poured all of his energy into math and he neglected literally everything else.
It's kind of heartbreaking to think about all the challenges that he faced, the poverty, the lack of support, even his struggles with illness. It would have been so easy for him to just give up at that point.
But he didn't. His dedication to mathematics, it never wavered. It was driven by this almost spiritual belief in the beauty and truth of his equations. And this is where this pivotal figure enters the story, Dewan Bahadur R. Ramachandra Rao.
His first real champion. So this is where things really start to change for him, right?
Absolutely. Rao was a district collector at the time, and he wasn't a mathematician himself. But he saw something truly extraordinary in Ramanujan's work. He described him as this short, uncouth figure with shining eyes, and he just refused to smother his genius by giving him some mundane, bureaucratic job.
So Rao recognized that his genius didn't need a fancy degree. It just transcended these traditional markers of success.
Exactly. Rao ended up providing him with financial support, allowing Ramanujan to dedicate more time to his research. And equally importantly, he connected him with the Indian Mathematical Society, providing him a platform to share his work and connect with other mathematicians.
But even with that support, Ramanujan still faced some hurdles. I mean, he struggled to articulate these complex ideas clearly and provide the rigorous proofs that are expected in academic mathematics. It really highlights the importance of having that mentor in your life, someone who can help you refine your raw talent and provide feedback, and just guide you through the complexities of your field.
Absolutely. And this brings us to what might be the most crucial turning point in Ramanujan's life, his decision to write to G.H. Hardy, who was a leading mathematician at Cambridge University.
Now that's a bold move. Imagine this young, unknown mathematician from India reaching out to one of the biggest names in the entire field. What was he thinking?
It was a leap of faith. It was a gamble that could have easily been ignored. And initially, Hardy was skeptical. He received letters from aspiring mathematicians all the time. It was hard to differentiate genuine talent from just amateur enthusiasm.
But then he started reading his work, and everything changed.
Absolutely. His skepticism quickly turned into astonishment. He was encountering theorems and formulas he'd never even seen before, ideas so radical that they challenged his very understanding of mathematics. Hardy later described Ramanujan's work as being on a different level, with some formulas so difficult and deep that they just left him baffled.
So Hardy realized that he was dealing with something truly extraordinary. This wasn't just another enthusiastic amateur. This was a mind unlike any he'd encountered before.
Exactly. And that recognition led to a pretty extraordinary decision. Hardy decided to bring Ramanujan to Cambridge.
Wow, what a moment that must have been. Two brilliant minds from completely different worlds, colliding on the hallowed grounds of Cambridge. It almost feels like the beginning of a movie, you know?
It really does, doesn't it? But before we delve into that chapter of Ramanujan's life, let's take a quick moment to reflect on what we've learned so far.
Yeah, okay, so we've seen those early sparks of genius, the unconventional path, the challenges overcome, and the just absolutely pivotal role of mentorship. I mean, it's a story of resilience. It's a story of raw talent colliding with this kind of established world. And ultimately, it's a story of how just a single letter can change the course of history.
Absolutely. And it raises this really interesting question. What happens when this intuitive, almost mystical approach to mathematics encounters the rigor and formality of Western academia?
That's exactly what we'll be exploring next as we delve into Ramanujan's time in England and those incredible achievements that followed. So picture this. Ramanujan arrives in England, this land of chilly weather and, let's be honest, somewhat bland food. Quite a culture shock, I imagine, for someone coming from southern India.
Oh, absolutely. And, you have to remember, this was wartime England. So even just finding basic supplies was a huge challenge. And Ramanujan was a strict vegetarian. He actually wrote to a friend back in India about surviving on mere rice with a little salt and lemon juice.
Wow, that's some serious dedication. I mean, willing to endure all those hardships just for his passion for mathematics. That really speaks volumes about his commitment.
It really does. But despite all of those difficulties, his time at Cambridge proved to be incredibly fruitful. He collaborated with Hardy, and their partnership, it really was one for the ages.
They say opposites attract. And I guess that kind of applies to mathematical minds as well, right? You had Hardy, who was the epitome of that Western mathematical rigor. And then you had Ramanujan, whose genius just seemed to spring from this pure intuition.
Exactly. It was this clash of styles, but it turned out to be remarkably productive. So Hardy, he helped Ramanujan formalize his ideas, providing those rigorous proofs that the academic world demanded. And in turn, Ramanujan's insights opened up these entirely new avenues for Hardy's own research.
I'm curious, did any specific stories or anecdotes from his time in England kind of stand out to you in the research?
Well, there's this one story that I think really captures his unique way of thinking. And it involves a fellow Indian scholar, P.C. Mahalanobis, who later became very famous for his work in statistics. So Mahalanobis was reading this puzzle from a magazine, something about houses on a street and their numbers, and he was kind of working through it methodically when Ramanujan came in.
Okay, I'm on the edge of my seat.
So Mahalanobis, knowing how brilliant Ramanujan was, he challenged him to solve it. And without even pausing, Ramanujan just glanced at the problem, and he immediately provided the solution using continued fractions.
Whoa. Talk about next-level problem solving. It's like he could just see the answer, almost as if it were already there, waiting to be discovered.
Exactly. And it highlights that intuitive leap that really set Ramanujan apart. For him, mathematics wasn't just about logic and formulas. It was like an art form, a way of expressing some deeper truth. He often said that, equations had no meaning unless they expressed a thought of God.
So while we're on the topic of his achievements, let's talk about some of those key areas of his work. We keep seeing these terms pop up. Partitions, Mach theta functions, infinite series. Can you break those down for us in a way that even a non-mathematician like myself can grasp?
Sure. Let's start with partitions. Imagine you have a certain number. Let's just say 5. Partitions are all the different ways you can add positive whole numbers to get to that number.
Okay, I think I'm following. So for 5, you could have like 1 plus 4, 2 plus 3, or even just 5 on its own.
You got it. Seems pretty simple, right? But as the numbers get larger, the possible partitions, they just explode in number. Ramanujan, along with Hardy, they developed these groundbreaking formulas and methods for calculating these partitions, which actually have implications in fields like number theory, combinatorics, and even physics.
Wow. So something that seems like, a pretty basic math puzzle actually has these profound implications in all these complex fields.
It really does. And then you have the Mach theta functions. These were described by Ramanujan in his final letter to Hardy, written from a sickbed in India. They're incredibly complex. Even Hardy, at the time, found them baffling.
So these were like his parting gift to the world of mathematics.
In a way, yes. It took decades for mathematicians to fully understand and appreciate just how significant these functions really were. And it turns out they have deep connections to areas like harmonic analysis and quantum physics, fields that were really just in their infancy during Ramanujan's time.
It's mind-blowing to think that he was laying the groundwork for fields of math that wouldn't even exist for years to come.
Absolutely. And that brings us to his work on infinite series. So these are those never-ending sums of numbers that sometimes converge to a specific value. Ramanujan had this uncanny ability to manipulate these series, coming up with these formulas that astounded even the most seasoned mathematicians.
And do those formulas have any practical applications?
They absolutely do. His work on infinite series actually has applications in all sorts of fields, like computer science, engineering, and even financial modeling. It's amazing how these seemingly abstract mathematical concepts can find real-world uses.
It's like this thread that runs through his entire life. This ability to just see patterns and connections that others simply couldn't grasp. But sadly, his time to explore these connections was cut short.
Yes, in 1917, his health began to deteriorate, and for years it was believed that he had tuberculosis, which was a very common diagnosis at the time for someone with his symptoms: weight loss, fatigue, and this persistent fever.
But the research that you shared indicates that might not have been the whole story, right?
Right. More recent research actually suggests that he may have been suffering from hepatic amoebiasis, which is a parasitic liver infection, and it's believed that he might have contracted it years earlier back in India.
That's so tragic to think that his genius was hampered by this potentially treatable illness.
It really is. And unfortunately, medical knowledge at the time just wasn't advanced enough to properly diagnose and treat it. But, despite his declining health, his mind remained incredibly sharp. In 1918, he received one of the highest honors in the entire scientific world. He was elected a Fellow of the Royal Society.
At the age of 31, no less.
And an incredible achievement, recognizing the profound impact that his work had already made. And later that same year, he was also elected a Fellow of Trinity College, Cambridge. These honors, however, they couldn't stop the inevitable. In 1919, he returned to India, hoping that the warmer climate would help him recover.
But it wasn't to be, was it?
Sadly, no. He passed away the following year at the very young age of 32. And it's a loss that the world of mathematics still feels today. What he might have achieved had he lived longer is a question that continues to intrigue and inspire mathematicians.
Yeah, it's hard to even fathom, what other breakthroughs he might have made, what other mysteries he might have unlocked. But even in his short life, he left such an indelible mark on the world of mathematics.
Absolutely. And while his work continues to be studied and celebrated, there's this one anecdote that perhaps best encapsulates both his genius and his unique personality. And it involves a visit from Hardy to Ramanujan in the hospital.
Okay, I'm intrigued. Tell me more.
So Hardy was trying to make conversation, and he remarked that the number of his taxi, 1729, seemed rather dull.
Dull taxi numbers. Not exactly the most riveting conversation starter, I imagine, especially between two brilliant mathematicians.
Well, and that's where Ramanujan's mind was so different. He immediately countered, saying that 1729 was actually quite fascinating because it's the smallest number that can be expressed as the sum of two cubes in two different ways.
Whoa. So in that moment, lying in a hospital bed no less, he could still see these intricate patterns and numbers that most of us would just completely glance over.
Exactly. And that's why 1729 is now known as the Hardy-Ramanujan number. It's a symbol of his ability to find this wonder and beauty in the seemingly mundane.
What a story. Kind of tragicomic, but it also really highlights the just sheer depth of his genius. But let's shift gears a little bit and talk about his legacy. What happened after his death? Did the world finally kind of recognize the full scope of his contribution?
Oh, absolutely. While he wasn't fully appreciated during his lifetime, the years following his death really saw this surge of interest in his work. Mathematicians started digging into those notebooks that were filled with his cryptic formulas and theorems.
Must have been like unlocking a secret vault of mathematical treasures.
It really was. They spent decades deciphering his notes, providing the rigorous proofs that were often missing. And by doing so, they opened up these entirely new avenues of research, making connections between what seemed like completely disparate fields of mathematics.
I remember reading about a lost notebook that was rediscovered in the 1970s. What was the story there?
Oh, it's quite remarkable. This notebook contained even more of his groundbreaking ideas, just further solidifying his place as a true visionary. It was like getting another glimpse into his extraordinary mind decades after his passing.
So his work has had this truly profound impact on the world of mathematics. But did he achieve any recognition beyond the world of academia? Did he become a household name?
Well, maybe not a household name in the traditional sense, but within the realms of science and mathematics, his name is absolutely legendary. There are institutes and research centers named in his honor. Prestigious awards are given out in his memory. And there was even a film made about his life, introducing his story to a much wider audience.
It's incredible how his influence just continues to grow, even a century after his death. It really makes you wonder what he could have accomplished if he had lived longer.
Yeah, that question continues to fascinate and haunt mathematicians even to this day. What if he had more time to develop his ideas, to collaborate with more mathematicians? His work, even in its unfinished state, has had such a profound impact. So imagine what could have been possible with just another decade or two of research and exploration.
Yeah, it's almost too much to even contemplate. But maybe that's part of his enduring legacy.
Yeah.
He leaves us with this sense of awe, this reminder that the human mind is capable of such extraordinary things.
Absolutely. And he inspires us to keep pushing those boundaries of knowledge, to keep searching for those hidden connections and those unexpected patterns, just like he did.
It's a powerful message. And as we wrap up this deep dive into the life and the legacy of Srinivasa Ramanujan, I hope you, our listener, are left with that same feeling of wonder and inspiration. He reminds us that genius can blossom in the most unexpected of places, that passion and resilience can overcome these seemingly insurmountable obstacles, and that even in the face of adversity, the pursuit of knowledge, the pursuit of beauty, it can truly illuminate the world.
Well said. Until next time, keep those minds curious, and remember, as Ramanujan showed us, there's magic to be found even in the most unexpected places.